you're going to visualize how this pointer code is physically laid out in memory so you can understand what's going on in this code segment here. I'm going to give a brief overview, which will be a review of what we've covered in class and in today's reading, but then I'm going to draw it out once we have our actual run. We know that the printout for those locations changes every single time we run it in the program because the operating system allocates a different location in memory. First, we know that we're going to allocate two registers, X and Y, and that's what's going on over here. We just have X and Y, and the physical location will contain the signed integer values of 10 and -20. That's going to have an address that we're going to call &x, and this one will be &y. Then we create pointers, X pointer and Y pointer, and that's going to be two other registers. X pointer's value is going to be &x, so that hexadecimal value is going to be represented here. Likewise with Y pointer, the value that's stored in that is &y, and then its own location is going to be &int x, and then &int y. So if you understand all of this, you have a good foundation of how computers work. So 10 we know in hexadecimal is going to be A. So we know that this first line is going to print 10, and then it's going to print A. This is going to be the location of int x. We see here &x points to here. Now here's the interesting part, and this is what's going to really help you. This X pointer is the value inside X pointer. Well, look at that. It happens to be &x. So we expect that these two values are going to be the same whenever the operating system allocates them. Finally, what we're going to see is &x pointer is not going to be the value inside. Rather, it's going to be the location of X pointer here. And then Y pointer is going to replicate all of these. We know that this will be -20. It's going to be translation into negative hexadecimal, and it's going to replicate everything. So let's compile it and run it, and then compare what we expect to what actually comes out in the compilation. So here I have the compilation, and now I'm going to run first pointer. And now let's take our knowledge of what we anticipate and compare it to what the memory layout is. So again, we know that X and Y are registers, and what they're storing is -10 and -20. We now know in hex it's going to be 0, 0, 0, 0, 0, 0, 0, A, because that's the binary representation. And inside here, this is going to be 6 F's, and then E, and then C. And that's the physical representation. These are located at these locations. So for simplicity, we're going to say that X is located at 0x48C. See this here, 48C. And then for simplicity, Y is going to be at 4A8. 0x, I'm sorry, this is not 8, it's A. And so this is X, and this is Y. So now we have those two other variables that we created, int pointer X and int pointer Y. We saw that that was created when we did these two lines of code where a pointer to X stores the address of X, and the pointer to Y stores the address of Y. So let's prove our theory. The next line of code indicates that the value inside X pointer, which we're going to call this here, X pointer, and we'll call this Y pointer. These contain the addresses. Well, if our theory is correct, we're going to have 48A and 48C. Here's 4AC, 4AC. Look at that. It's the exact same thing. 4AC. And then this is going to be 4A8, 4A8, 0x 4A8. And that's what's going on, this actual physical representation of what's going on inside. Then ampersand X pointer is the location. So that's 0x 4A0. And then Y pointer, physical location, is 0x 498. So it's physical location. When we print it out, 4AC is a pointer here, and 4A8 is a pointer here. So that is basically how these pointers are laid out fundamentally.